Hello guys, how are you? I hope everybody doing good. Today we're going to have hexadecimal. Today lesson number 5 from course number 1. It's about hexadecimal. So, all right, let's ask ourselves a question. What is hexadecimal system? Before we go to know what is hexadecimal system, we should to remind ourselves that decimal system it's base 10 and binary system it base 2. Hexadecimal is base 16. Hexadecimal is base 16. And how we represent the numbers after 9 in hexadecimal, that's what we will see it now. All right, this is base 16 hexadecimal. As you see, from 0 to 9, like decimal numbers, like decimal system. But number 10 in hexadecimal, we represented as a letter A, and number 11 as a letter B, and number 12 as a letter C, till the end, number 15 as a letter F. So hexadecimal system is base 16, and the numbers after 9, we represent it with some letters, which is from A to F. And this is small table. This is small table explain to you that the number from 0 to 9 in decimal, same in hexadecimal, from 0 to 9 hexadecimal, same. But number 10 in decimal is different in hexadecimal. Number 11 decimal, it's different in hexadecimal. And that's how you write it, or how we represent the decimal and hexadecimal numbers in binary. And if you don't know why we represent these numbers in binary like this, or why this normal number of decimal or hexadecimal look in binary like this, you should to go and watch the video of binary system. You will understand everything there. All right, so this is the numbers in binary system. This small table just to explain to you the difference of hexadecimal and decimal, between the hexadecimal and decimal. All right, why hexadecimal? Why they create for us hexadecimal? What we need it as a developers, we as a developer, why we need hexadecimal? Because it's hard for human to read binary. As we said, and we give example in binary system video, we said what this mean, these numbers that you saw it now on the screen, what it's mean? It's mean I love you. When you send to your girlfriend, as we said in the night, to your girlfriend, I love you, computer take it, change it, or represent I love you words in these numbers. So it's hard for the human and developers read binary system or binary code. For that, they create for us hexadecimal system. So let's have a small example. The hexadecimal, it provides a human-friendly representation. Example, these numbers that you saw it, this is the small number of the binary, 1, 10, 10, 100, is same in hexadecimal T4, D4. You as a developer, it's better to you to read D4, or it's better to you to read all this number of binary? For sure D4, it's easier to you. For that, it's hexadecimal, it's like make it easy for the developers to read the code and understand what the code is. Instead, they read binary system numbers or code, and it's more complicated. So for you as a developer and even normal human, it's better to you to read it D4 than all these numbers. And each byte, we said 8 bits, it's 1 byte, it gives us 1 byte. So each 1 byte in binary represent 2 letters or digits in hexadecimal, which means instead you read 8 bits, instead you read whole 1 byte in binary to understand what does this mean, or this code represent what number or letter or sentence, or what is it. And it's more complicated and hard, and it's not human friendly representations for the human. So they make it short for you and easy. They take the 1 byte and they create hexadecimal, and they represent whole 1 byte, which means 8 digits, 8 bits together. That it's 8 bits, we said it's 1 byte. So 8 bits together, which mean 1 byte. They take this 1 byte and they change it to just 2 letters or represented with 2 letters only. So D4, it's same of this binary code number. Let's have an example, another example. As we said, now D4 is, this binary number is D4, and this whole binary numbers, that all of it 11111111, it's represent in hexadecimal 6Fs. It's better to you as a developer and human to read 6Fs, or it's better to you to read whole this binary number? For sure 6Fs, like 6 times of F letter, it's easier than this binary number. It's better also to you to read double F and 4 zeros, or to read whole this binary number. For sure, as a developer, it's better to me to read double F and 4 zeros and understand it more easy and read it more easy. It will be more readable and more easy to read it. So each byte, as we say, is represented with 2 letters only. And if you go to any application, not any application, like if you work in HTML, CSS, you will get it later in future courses. We're still far away from it. In web application roadmap, but we're still far away from it. Anyway, if you open, for example, Photoshop application, everybody knows what's Photoshop, and you want to choose color or any editing video application, and you want to choose color, we have window, we called it color picker. This window that you saw it now on the screen, we called it color picker. Always color picker, you will find when you choose the color, always this down hashtag and 6F. When you choose different colors, always down this hexadecimal number. It's always changed, depends about the color that you choose it on color picker. Here, as you see in this color picker, hashtag 6Fs, it's represent white color. Hashtag 6Fs, 6 times of F letter, is represent white color. And this color and this hashtag double F 4 zeros, it's represent red color. So it's more easy to me as a developer to read this letter number better than to put for me whole that binary number. And this just table explain to you the CSS color names and the hexadecimal code and decimal code. If you will focus here, hashtag double F 4 zeros, hashtag double F A 500, hashtag 4 times of F and 2 zeros. What this hashtag before each hexadecimal code? It represents what this hashtag? All right, we have something called prefix. We have something called prefix. For example, in this small table, we have the first column technology and languages. HTML and CSS, its prefix, these 2 languages, its prefix is started with hashtag and the code. For example, here hashtag and 6Fs. And C language and C++ and Java, their prefix or its prefix 0x, and after that the code. For example, here 0x and C2A4. XML, you will know what XML in future in course number 9. The prefix, it's sign and hashtag and the code. And if you use Unicode prefix, it's U plus, and after that it's code. So this is just a clue about the hexadecimal and how it's more easier than the binary, and the developer, they use it so much than the binary because it's more easy and represent the code more easy than the binary. And the prefix, the different prefix for each languages, I give you like clue about some languages. And the hexadecimal will not use it just in colors. Hexadecimal code will not just use it for colors. We could represent it, we can use it for any code, for anything you want. You will know in future also when we use it in our courses in future, if in web roadmap. So how hexadecimal works? Now we should know how hexadecimal works. But before we go to see how hexadecimal system works, we have to remind ourselves that binary was base 2 and hexadecimal is base 16. And this is the base of 16 up on the screen if you saw it, from 0 till 15. And number 10, it's represent as a letter A in hexadecimal base, and it's base 16. So let's convert this number 469 to hexadecimal, normal number from our human number, 469, normal number. 469, we want to change it to hexadecimal. All right, the rule that we will use it's like as you saw it on the screen. We will take the number 469, we'll divide it by 16. Why 16? Because hexadecimal base 16, and we will get result 469 divided 16. We will get number, we will get results. We will take these results, we will spread them. We will take from it the integer number, we will put it in different column, and we will take the fraction of this result, we will put it in different column. And after that, we will take the fraction, we will multiply it by 16. Why 16? Again, because hexadecimal is base 16. And we will get after that the final number or the result. Let's see how it's work. 469 divided 16 equal, it's give me 21.3125. So we take 29, we put it in integer, sorry, 29, not 21. 29.3125. So we take the 29, we put it in integer column, like we separated, and we take the fraction, we put it in the fraction column, 3125, and we take the fraction, we multiply it with 16. 16 multiply 0.3125, it gives us 5. All right, and how it's work after that? We take 29, the integer number, we divide it 16. Why we take 29, we divide 16? Why we not stop till here? Because while the integer number still bigger than the base 16, then the base then still bigger than the number of the base. The number of the base what is 16? 29, it's bigger than 16. So while the integer number bigger than 16, we will repeat again the math that we do it now. So 29 divided 16, it will give me a result. The result is 1.8125. We'll take the one, we'll put it in integer column. We'll take the 8,000, we'll put it 8,125, put it in fraction column, and we will take the fraction. We will multiply it with 16. So 16 multiply 8,125, it will give me 13. And 13, it's represent what in hexadecimal? It's represent letter D, as you saw it up. I put it up on screen. And while the number of integer now, the last number of integer now, it's 1. All right, while the number of integer less than the base number, less than 16. Why 16? Because hexadecimal is base 16. I repeat it to you to understand. Do not ask me later why I just do it on 16, because hexadecimal is 16. All right, while the integer number, the last integer number, it's smaller or less than base 16 number, which is 16. So the result, it will be the same, it will be 1. So if we say 1 divided 16, it will give me 1. All right, now we have 1, we have 5, 13, 1. We have from the first math that we do it, 469 divided 16, and we get result, and we multiply it with 16, this give me 5. And after that, the 29 divided 16, the result, it's give me 13. And in the end, 1 divided 16 is give me 1. So I have 5, 13, 1. 5, it's represent in hexadecimal up what? It's represent 5. 5, it's 5. Number 13, it's represent in hexadecimal what? It's represent D, letter D. 1 in hexadecimal, number 1, normal decimal number 1. It's represent in hexadecimal what? 1. All right, so how we read it? How we read the hexadecimal? Now we have hexadecimal number 5D1. How we read it? We read it from down to up, from bottom to up, from bottom to up, from down to up. 1D5. Like this, we read the hexadecimal numbers from down to up. 1D5. So 469 in base 10 decimal system, it's same 1D5 in base 16. All right, let us have another example. Let's convert 479 to hexadecimal, to hex. All right, we'll do the same process that we do with the last or the previous example. We will take the number 479, we'll divide it 16, we get result, we'll put the integer number in integer column and the fraction number in fraction column, and we multiply fraction multiply 16, we will get a number. All right, so let's start. 479 divided 16, it's giving me 29.9375, and the integer number is 29, and the fraction number is 0.9375. and we will take the fraction number, which is 0.9375. We'll multiply it with 16. So 16 multiplied 0.9375 equal 15. And while, as we said in the last example, while the integer number bigger than the base number, which is 16, because hexadecimal base 16, while the integer number bigger than hexadecimal number, the base of the system, bigger than 16, we will repeat the process again. So 29 divided 16, it's give me 1.8125, the integer number 1, the fraction 8125. 16 multiply 8125, it's give me 13, and the integer number, it's 1, so 1 divided 16, it's give me 1. Now we have 15, 13, 1. How we will read it? First, what is represent 15 in hexadecimal? 15 represent number F, letter F. Number 13 represent in how we represent it in hexadecimal? We represented number D, and 1, it's 1. And as we said, we read hexadecimal from down to up. So 1DF. 1DF in base 16, it's same exactly like 479 base 10 decimal system. 479 base 10 decimal system is same exactly, totally same like 1DF in base 16. And you can do the math by yourself to make sure and do practice on it with the homework that I will give you now, and don't underestimate it. You should to practice, you should put your hand in this work to be better and better and good developer. So now let us jump to the homework. I want you to convert those decimal numbers to hexadecimal and put it in the comments down below, please. Convert for me these decimal numbers. 4,722, 7,221, 256, 4,444. Convert them from decimal numbers to hexadecimal and put them down. Put just the number of the hexadecimal, like the result of the hexadecimal number after you did the process, the math. Put just the number of each one of these. And thank you guys for everything. See you next lesson. Ciao.